Hello students, we are solving the IB Math EA past paper questions and currently we are solving questions from the IB Math EA November 2022 paper 1 past paper. Today we will be solving question number 11 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in my channel NS Online Math Tutoring Classes. So without any further delay, let us start answering question number 11. The maximum mark is 60. Consider a three-digit code ABC where each of A, B and C is assigned one of the values 1, 2, 3, 4 or 5. Subpart A's question is, it is containing two further subpart and it is saying that find the total number of possible codes. First subpart says, assuming that each value can be repeated, means you can have 1 2 1, you can have 1 1 1, you can have 4 4 4. Each value can be repeated. Okay. So this is subpart A, I. Each value can be repeated. There are three values A, B, C. So three places. So for this place, I could have started from the rightmost place also. I'm starting with the leftmost place. There are five options. And so multiplication. There are five options for the middle one. And so multiplication. There are five options 1, 2, 3, 4 or 5 for the last one. So total is 5 times 5 is 25 times 5 is 125. Okay. So total number of possible codes is 125 codes. Okay. And I is assuming that no value is repeated. Again, you are having three places. I'm starting from the leftmost one. For this leftmost place, I can place any of these five letters, five digits rather. So there are five options for this place. And so one has been taken out of 1, 2, 3, 4 or 5. One has been taken. One number has been taken. So there are four numbers remaining. So there are four options for the middle place. And finally, there are three numbers remaining. So there will be three options for the rightmost place. Therefore, number of codes possible will be 5 times 4 is 20, 20 times 3 is 60. Okay. Let P of x equal to x cube plus ax square plus bx plus c, where each of a, b and c is assigned one of the values 1, 2, 3, 4 or 5. Assume that no value is repeated. Consider the case where P of x has a factor of x squared plus 3x plus 2. Okay, and subpart B, it is having four subparts. Subpart I's question is find an expression for B in terms of A. So this is a quadratic factor. Let us factorize this to get two linear factors. Okay, so this is x squared plus, I can write this as x plus 2x plus 2. So this is x plus 1 plus 2 x plus 1 and this is x plus 1 and x plus 2. Okay. So these are the two linear factors of P of x. It should be having three linear factors because this is a a cubic function. But we know these two linear factors. And since these two are factors of P of x, so if I substitute -1 in place of x, That means P of, this is subpart B, I. P of I, sorry, P of negative 1 is equal to 0, should be equal to 0 because x plus 1 is a factor. Okay. And also P of negative 2 should also be equal to 0. First of all, P of negative 1. What is P of negative 1? We will be substituting negative 1 in place of x. So, negative 1 whole cubed is negative 1. Okay. Negative 1 whole square, x square is negative 1 whole square, that is 1. Positive 1 times a is a. B times negative 1 is negative b, and plus c should be equal to 0. Or I can rewrite this as a minus b plus c is equal to 1. Okay, this is our first equation. Why am I numbering this equation? Because I have to get a in terms of b, or rather b in terms of a. And we know that p of negative 2 will also be equal to 0. So I'll be substituting negative 2 in place of x. Negative 2 to the power of 3 is negative 8. So negative 8 and negative 2 whole square is 4. 4a plus 4a. Negative 2 times b is negative 2b plus c is equal to 0. Or this implies 4a minus 2b plus c is equal to 8. Okay, this is our equation number 2. Let me just bring in this equation 1 over here. It is a minus b plus c is equal to 1. And we have to get b in terms of a. So let us eliminate this c. How to eliminate this c? We will be subtracting. Since we are subtracting, the signs will get changed. So you will be having, these two will be getting cancelled. So 4a minus a is 3a. Minus 2b plus b is minus b. And 8 minus 1 is 7. So b in terms of a. Therefore, b is equal to 3a minus 7. Okay. We have answered subpart I. Now coming to subpart I. I hence show that the only way to assign the values is a equal to 4, b equal to 5 and c equal to 2. Okay, let us check. First of all, let us restrict ourselves to a and b values. Okay. And since the numbers are 1, 2, 3, or 4, or 5, first of all, I'm taking a is the independent variable, b is the dependent variable. So I'm starting with a as 1. Okay. When a is equal to 1, what is the value of b? 3 times 1 is 3. 3 minus 7 is minus 4. So b should be equal to minus 4, cannot be taken because a, b, c can have values 1, 2, 3, 4, or 5, and no value can get repeated. So this cannot be taken. So what about 2? 3 times 2 is 6, minus 7 is minus 1. This cannot be taken. 3. 3 times 3 is 9, minus 7 is 2. This can be taken. 4. 4 times 3 is 12. 12 minus 7 is 5. can be taken. What about 5? 5 times 3 is 15. 15 minus 7 is 8. We have to have ABC values between 1 to 5. So this cannot be taken. If you take, okay, this is the maximum value that A can have. So only these two can be taken. A equal to 3 and A equal to 4. But they are saying only this can be taken, not A equal to 3 and B equal to 2. So how can we reject this? Let us see. For this, let us take the equation 1. Okay. From equation 1, A plus, A minus B plus C is equal to 1. A is equal to 3. So implies A is equal to 3, B is equal to 2, plus C is equal to 1. So 3 minus 2 is 1. 1 plus C is equal to 1, which is implying that C value is equal to 0, cannot be taken. Because the numbers that we are having are 1, 2, 3, 4, and 5. So this also cannot be taken. So this is the only combination that is remaining. A is equal to 4, B equal to 5. So what is the value of C? So A, again I am writing A minus B plus C is equal to 1. So A is equal to 4 minus 5 plus C is equal to 1. 4 minus 5 is negative 1. Therefore, C is equal to 2. C equal to 5, E equal to 4, B equal to 5, and C equal to 2. Okay. Therefore, A equal to 4, B equal to 5, C equal to 2. Okay, now I express P of X as a product of linear factors. So P of X was x cube plus ax squared plus bx plus c. Okay. So fine. I P of x is equal to x cube plus ax squared. In place of a, I am writing 4 x squared plus bx, that means 5x plus c, that is 2. Okay. So, and this was equal to this will be having 3 linear factors. The first two were x plus 1 and x plus 2. So let me write this as it can be x plus k, x plus 1, and x plus 2. Okay, and we have to find the value of k. We are seeing this is the y-intercept 2. And 2 can be obtained when we multiply k with 1, and k times 1 times 2 will be equal to 2. Okay, so therefore k times 1 times 2 is equal to 2, or k is equal to 1. Okay, therefore p of x, this is x plus 1, this is x plus 1, so you are having a repeated root, x plus 1 whole square and x plus 2. Okay, so the zeros will be x equal to negative 1, where you are having the repeated root, and x equal to negative 2. And finally, the fourth subpart is hence or otherwise sketch the graph of y equals p of x, clearly showing the coordinates of any intercepts, that is the x-intercept and the y-intercept, with the axis. Okay, and this full subpart B is containing 12 marks. Okay, so this is the cubic graph. You see, the y-intercept has to be x coordinate will be obviously 0. It will be on the y-axis, and the y value will be 1 square is 1 times 2 is 2. So this is the point 0 comma 2, and you are having a repeated root. That means the graph will be touching the x-axis at this point. It will not be crossing the x-axis, and it's negative 1. So it is this point. It is touching the x-axis at this point, and this is a single root. So at x equal to negative 2, it is crossing the x-axis. And since x cube is having the positive sign, so the graph is starting, it is moving towards the positive infinity. As x tends to positive infinity, y is also moving towards positive infinity. Okay, because the x cube is having the positive sign. So this is the graph for the p of x, the cubic expression, and we have shown the x-intercepts, and we have also shown the y-intercept. So that was all for this fourth subpart, and that was all for this question number 11. Thank you for staying with me till the end. I am Nilanjana Sanyal. I'm an online IB Math ASL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services to my students. And currently, I am uploading these past paper solutions of IB Math AHL in my YouTube channel. And in case you are liking my explanation, please to give this video a like, and please to share this video with your friends so that even they can get benefited by watching this video. And in case you have not subscribed to my channel till now, please to subscribe to my channel. It will be motivating me to make more math videos for you. Okay, and in case you have any question, any doubts, please feel free to write to me in the comment section. I'll be reading your comments, and of course I'll be answering them. Okay, so get a stop over here for now, and we meet again in our next session where we'll be solving the question number 12. That is the last question of the same paper. So till then, bye.